Hello everyone, my name is Abel Diaz, and in today's video I wanted to talk about reaction forces and moments. So to get started, I wanted to talk about the different types of support systems or support types that we have. Let's say we have a beam here, and this beam is being supported by a pin. Let's call this point A. At this pin support, we only have two reaction forces, that being a force in the y direction and another force in the x direction. Pin. This is because we are able to move our beam in both the x and y direction. Our next type of support system or support type is a roller support. So let's say we have a beam, and that beam is being supported by a roller. Now, if we have a roller support, we will see that we only have one reaction force, and that reaction force is going to be here. Let's label this B. So this is going to be BY. And if we move to our next type of support system, our fixed support, we'll notice that we have three reaction forces. So we'll have our simply supported beam, which is fixed. And we'll have three reaction forces. We'll have a reaction force in the y direction. We'll have a reaction force in the x direction, and we'll have a moment. Shoot, that's horrible. A moment. Now, these are three common types of support systems. There's also others like a hinge, and the hinge also has two reaction forces. Now, let's see. A hinge, kind of, you could think of maybe like the little ring on the lanyard. But yeah, so this is our hinge, and that's gonna have two reaction forces here and here in the y and x direction. So now that we've talked about our support types, support types, we could talk about moments. So we know that a moment is equal to a force multiplied by a distance. The force being applied, or the force we're focusing on, and the distance being a distance perpendicular, so I guess perpendicular to our force. Now we could, there's also a thing called couple moments. So a couple moment, let's write it down, couple. And a couple moment is created when we have two forces. So let's say we have a force here. This is our first force. And our second force is pointing the opposite way. So if we have two forces and they're the same magnitude or the same type, like the same force being applied in the opposite directions, and they're separated by a distance here, then we're going to have a couple moment being created, because as you can see, we have this force here multiplied by this distance, and then same thing over here, this force over here multiplied by this distance here. So that's just something to know as well. So we have our couple moment, and then this is our moment. I guess I'll just highlight our underline moment. So now I guess something else we could talk about is the units associated to a moment. So I guess let me write that down here. Units. So since it's a force multiplied by a distance, we're going to have the units of a force and a distance. So some common units include newtons multiplied by meters, pound times feet, or kips And I think there's more, but kips times inches. I mean, I think there's more, but I'm not too sure. Or of which ones right off the bat. But now that we have those two definitions out of the way, we could, I guess, try to solve for a problem here. Alrighty, to start this example, we could use the information we just talked about. So for our pin support here on the left side, we're gonna have a AY reaction force and a AX reaction force. And for the roller support over here on the right side, we're gonna have just one reaction force, which is our dy. Now, what I would do is break down this distributed force here first. So this distributed force we could simplify into just I guess a concentrated force here in the middle by multiplying the 500 pound per foot by the distance where it's being applied, or where this concentrated force is being applied, and or I guess the total force, sorry about that, my bad, or the total distance, which is 10 feet. So this distance here multiplied by this force here, and if we do that, it's going to cancel out our feet and give us that concentrated force, which is going to be 5,000 pounds. So I'm just going to erase my math here a little bit, clean it up. So that's 5,000 pounds. I'll just rewrite it here. 5,000 pounds. Okay, so we simplified that. So I guess we could start off with our equilibrium equations. So we know that the first one is going to be the sum of forces in the x direction. And we set that equal to 0 because it's in equilibrium or static. Alright, so we could look at all our forces in the x direction. And if we look at that, let's define positive is going to the right. So if we look at our x, I guess, forces, the only one we have is this 1,000 pound here, or 1,000 pounds going to the left. So what we could do, and that's actually wrong. We also have our AX reaction here. So we're going to solve for that AX reaction. So basically what we could do is do this AX, let's color code this, I guess. AX, which is going in the positive direction, so it's positive, and then minus that 1,000 pound, which is going to the left, so that's negative, is equal to 0. So then what we know from that is that AX, from some simple algebra, just moving the 1,000 to the other side, AX is equal to 1,000 pounds. So that's our first reaction force that we just solved for. So now we know that this AX is equal to 1,000 pounds. So now we could go ahead and solve for the other reaction forces, such as, I guess we could start off with AY or DY. Let's start off with DY. So what we could do to find DY is take the moment at, let's take the moment at A to find dy. Yeah, that I think, yeah, that's what we should do. So if we take the moment at A, oh shoot, my bad, moment at A, and then set that equal to 0, equilibrium, and define our positive direction as counterclockwise, we could see that based off our moment definition, which is force times distance, we could see that we have multiple moments being created here. So if we, I guess the first one we could look at is our dy moment being created. So if we're taking the moment at A, so A being over here, we have this force here and this distance here. So what we're going to do is multiply our force times our distance. Now, our distance from A all the way to dy, where that force is being applied, being 20 feet. So we multiply by 20 feet. Let me change the color because that might be a little confusing. Let's do orange. Why not? Orange for the distance here. Let me get orange in here. Cool. So we have dy times the 20 feet. And now we can move on to the next one. Oh, also, when you're doing this, you might want to try to use your pencil as the beam and apply the force onto your pencil with your finger. And based off of the direction your pencil is going, that's the direction or the I guess the like whether that's going to determine whether it's going to be a positive force or a negative force. So I guess it's going to determine the sign of your force. So for example, this dy, if we have our pin support, so we hold it at that end on the left side with our finger and hold it as a pin support, and we put our dy reaction force pointing up on our pin, or not on our pin, on the tip of our pencil, we'll see that it moves counterclockwise. So let me do a little quick drawing for you guys. So let's say you're holding your pencil here. That's your pencil. Horrible drawing. Let's just say you're holding it with your two fingers here, and that's creating a pin. The pin, I guess simulating a pin support, because it's able to move up and down, right? Anyways, so basically, if we put a dy here, it's gonna cause it to move up, and that's counterclockwise, right? So that's how we know our force is gonna be positive for this first one. Now, if we move on to like our next moment, let's see. Let's focus on this 3,000. We could multiply, or that 3,000 is gonna be around over here. 3,000. Let's forget about our dy. If we have that 3,000 force, our pencil's gonna be moving down, which it's going to be moving clockwise, which is not positive in our case because we define positive as counterclockwise. So our next force is going to be negative 3,000, and we have to multiply it by that force. So the force from our moment we're taking at A is going to be 5 feet to that 3,000. So we're going to multiply by 5 feet here. Okay, so next we're gonna see if we have any more. So we have that 5,000 concentrated force of the distributed load, which is also creating a moment. So what we could do is, I guess, also put that 5,000 like this, and that would also make it go counter or clockwise, which is not positive, it's negative. So if it's moving clockwise, that's negative. So our force is going to be a negative 5,000 multiplied by the distance. Now our distance here being from from A all the way to where the concentrated 5,000 applied force is being applied at. So that's going to be 5 plus 5 plus 10. Wait, no, it's not. That's going to be, I think that's 15 actually. Yeah, that's 15 because here's just 5. So it's just 5 plus 5 plus 5. So 15. Bam. So we multiply by 15 here. And we look and check if we have any more forces which are creating moments, which we don't. It doesn't look like we do. But it's important not to forget about this moment, which is already being shown here. So this 2,000 pounds here is a moment that's being represented by that little arrow, which I just highlighted, or like, I guess, drew over. So that's going counterclockwise, so we know that's going to be a positive moment. 1,000 is equal to 0. Alrighty, so let me get my calculator very quickly. I'm probably going to have to cut the video really quick. Alrighty guys, I'm back. I'm going to go ahead and just do all this math and show you guys everything. That way you guys could see step by step. So we have negative 3,000 multiplied by 5 feet. That's going to give us 15,000. I definitely did not need a calculator for this. Oh well, it's whatever. I'm still going to use it. So we have 5,000 multiplied by 15. And that's negative 5,000, by the way. And that's going to give us 75,000. And we have that plus 200, or 2,000, which is equal to 0. And then we could bring down this, multiplied by 20 feet. Alrighty, we could add all these, or just, yeah, basically. So we have negative 15,000 minus, or I'll just, yeah, minus 75,000, bam, bam, plus 2,000 is equal to negative 88,000, which is equal to 0. And then dy times 20 feet is so here. So we could go ahead and move this 88,000 to the other side, canceling it out over here. And now we could solve for dy, which is equal to, sorry. So to get dy alone, we could divide by 20 feet here. And then over here, I guess we could have our units, which LB times feet. Yeah, I didn't put my units for these, but these are all LB. And then LB times feet. So then our units over here, well, this is just LB, I think. B. Okay, anyways, guys, oh, no, LB times feet, because it's a moment. Okay, yeah. So now, since we're dividing by that 20,000 feet here, our feet get canceled, and we get dy is equal, so let me do that, 88,000 divided by 20 is equal to 4,400 LB. Okay, and that's pounds because our feet get canceled. So now we just solved for our second reaction force. So we know now that dy is equal to 4,400. So dy is equal to 4,400 pounds. Okay, so far we've solved for the reaction force in our AX, I guess, direction, and our dy direction over here at point D and at point A. So now we could go ahead and solve for our last reaction force, which is AY. Now, I think this one's pretty simple. To do this one, all we have to do is sum up the forces in our y direction. And we could define up as positive. So let's put that to the side and let's set that equal to 0. So let's look at this. Our first one we have is AY. So AY is going up. So we have positive AY. Our next one is 3,000. So and that's pointing down. So it's going to be minus 3,000, guys. Bam, bam. And let me just zoom out. Then next we have negative 5,000 because it's going down. And then we have dy, and that's going up. So that's positive. And that's equal to 0. I think those are all. Yep. So now that we have this, we could just do some simple math. So we could solve. Oh, and we could actually plug in now for dy because we know dy is 4,400. So we could plug that in. So we have AY minus 3,000 minus 5,000 plus 4,400 is equal to 0. So I'm just going to plug that into my calculator very quickly. So negative 3,000 minus 5,000 plus 4,400 is equal to negative 3,600 pounds, which is equal to 0. Move that 3,600 pounds to the other side. 600 pounds to the other side. AY is equal to 3,600 pounds. So that's how you solve for the reaction forces for a structure based off of, I guess, the support types given to you. Thanks for watching. I hope this video was helpful.